Let's talk about switches and what they do. Switches look like this in a schematic. This is a typical Cisco schematic here. Often when I draw them, you'll see me draw them something like this, which is an arrow in each direction. If this were a hub, I would just draw a single arrow in one direction. This is what a switch actually looks like, and you see a number of ports here. And we'll talk about the ports in another video. And then you see some kind of different looking ports over here. The same type of plug that goes into them, but they have a different function. And then yet another one on the other side of the thing called a console port. You can't see that. That would be over here on the back side of this. So what do switches do? Well, there are really three things that they do. First of all, they connect multiple devices to a single router port. Remember that each port on a router is a different network. But if I want a whole bunch of computers here on one network, well, I can't plug them all into this one port on the router, but I can plug them into all these many ports on a switch, and then plug that switch into the router, and that way I can have many devices on the same network on this router. So that's the first thing that switches can do. The second thing switches can do is to segregate the devices here by collision domains. Now normally, if this were a router, if one PC sent a piece of information out, a frame out, everybody would hear it on a hub, but not on a switch. With a switch, if PC1 wants to talk to PC3, that frame is only sent out to PC3. Here PC4 is talking to PC2, and that frame is only sent out to PC2. So the switch does all that orchestration and creates different collision domains. Each of these PCs is on a different collision domain. So how many collision domains do we have here? Well, I've got one here for PC1, another one for PC2, a third one for PC3, a fourth one for PC4, and don't forget this one over here between the switch and the router is also another line coming off of the switch, so that would be 5. I've got 5 collision domains on this switch right now. So the second thing that switches do is to create separate single unit collision domains. The third thing that PCs do, or that switches do, is to create something we call VLANs. Now, VLANs are groups of computers that have their own IP address, their own subnet. So a switch, even though a switch is a layer 2 device and normally doesn't care about IP addresses, in this case, we do care about IP addresses. We can create an IP subnet off of whatever group of ports we want, and then another one off of a different group of ports, and another one off of a different group of ports, and so on. And each of these is its own IP subnet. Now, these computers in this subnet cannot talk to these computers in this subnet. They're on different networks. So unless we have some way of communicating between these things, they can't talk to each other. There are a couple of ways to do it. One is to use what we call a layer 3 switch, and that has some routing capability in order for VLANs to be able to talk to each other. Now, it's not a full-blown router. It doesn't have a lot of the other features that routers have, but it does allow us to talk to these inter-VLAN routes here. The other way we could do it would be simply to put a router up here somewhere, and then a line from the switch to the router, and let that router do the routing, so that if this computer over here wanted to talk to one over here, that information would go up to the router would do the routing, and then it would come back down and go to this other VLAN over here. So the third thing that we can do with switches is to separate or segregate devices into subnets, which we call VLANs. And that's it for what switches do. We'll talk about individual characteristics of switches in other videos.